Now I am explaining a new topic. Topic is random variable and its probability distribution. Now to understand words and terminology in this definition, I am taking one example, because if I will explain directly without example, then you will not be able to understand this terminology and these terms. So that's why every word I am explaining by example. Say here an urn contains 5 red and 2 black balls. In a box there are 5 red and 2 black balls. 2 balls are randomly drawn. So in this experiment, of drawing 2 balls randomly, sample space is associated with this experiment is S is equal to, say in this box there are 5 red balls and 2 black balls. So from this on we are taking 2 balls. 2 balls are taken with replacement or without replacement. Do by any method. So see which are possible outcomes. If you take first ball, so first ball can be of red color. Second ball can also be of red color. This is first possible outcome, with or without replacement. Now second possibility, first ball red, now take second ball, it can be black. Third possibility, first ball can be black, third ball red. Fourth possibility, both balls can be of black color. If you do this experiment with replacement or without replacement, because we are taking 2 balls in both the cases, with replacement or without replacement, this is the sample space. So see, let S be the sample space associated with a random experiment. So this is sample space. Now we are given that X represents the number of black balls. So here X represents number of black balls. Now see, here a function X whose domain is S. See, X is a function, its domain is S. So domain is here, this is domain. Let me write here. Say X is function whose domain is S. This is domain. Codomain is R. So this is a real valued function. X is from S to R. Now in any function we are allowed to put only elements from its domain. Every function can work only on elements of its domain. So this function X can work only on these 4 elements. So here see, from given, this is given, X means number of black balls. So that means in this function, if you keep RR, that means number of black balls. In RR. So in these 2 balls, number of black balls is 0. So number of black balls is 0. Now we keep RB. See, this is a function. Any function can work only on its elements of a domain. So we keep one by one elements in this machine, and this is the working way of a machine. Okay, what X does? X is a machine which calculates number of black balls. Now in this machine I am putting RB. So that is number of black balls in RB. So in this selection, number of black ball is 1. Similarly, X of BR. So number of black balls in BR. Again, in this selection there is one black ball. So number of a black ball is required. X of BB. So number of black balls in BB is 2. So therefore, range of X is 0, 1 and 2. Say here, X has this set as domain, and X in this machine, these elements are taken and X works on these elements, and outputs are 0, 1 and 2. So this is range of this relation. So here you can see that when RR is taken, image of RR is 0, image of RB it is 1, image of BR it is also 1, and image of BB is 2. 0, 1, again 1, 2. So here it is a many one relation, and outputs are real numbers. Because it is many one relation, this is a many one relation and outputs are real values. So this is a function. So therefore range of this function is 0, 1, 2 and it is many one relation. So X is a function. It is real valued function. So X is a random variable. It is a random variable. So in this procedure, these are like a UI. See, from set S, these are UI. UI belonging to S. UI are taken in X. So it is X of U1. X of U1 is X1. X of U2 is X2. See, look here, X of U1 is X1, X of U2 is X2, X of U3 is X3, X of U4 is X4. So these are UI, and X takes these values, so it is range. So set of Xi, this is set of Xi, it is range, and because it is a function, it is a random variable. Next question, let X represents the difference between the number of heads and number of tails obtained when a coin is tossed 6 times. So here experiment is when a coin is tossed 6 times, See, if you toss a coin 6 times, then see outcomes are like this. Suppose H, H, T, H, T, H. This is one of the possible outcome. Total number of outcomes performing this experiment is 2 into 2, 4 into 2, 6 into 2, 12, 2 into 2, 4 into 2, 8 into 2, 16 into 2, 32 into 64. We can get such 64 outputs. When a coin is tossed 6 times, these are few examples of outputs. See, we can get similar outputs. Coin is tossed 6 times, number of outputs 2 into 2 into 2 into 2 into 2 into 2, that is 64 outputs. There are 64 outputs. Sample space contains 64 outcomes or sample points. These are few outcomes from collection of 64 outcomes. Now experiment is what X does. See, here X is a function. It is a function from S to R. These elements are in S. So X can work on elements of S. So X in this machine we can put H, H, T, H, T, H like this. Now what X does? Here X calculates, X represents the difference between the number of heads and the number of tails. X calculates difference between number of heads and number of tails. Now see, look here, number of heads 1, 2, 3, 4. Number of heads 4. Number of tails 2. So what is difference? Difference is 2. If we take this element, suppose X works on this element T, 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 H, H. What we are doing in X machine, we are putting elements UI. See, in X we are putting elements from sample space U1, U2. Just I have taken U2 and it calculates this value by this given definition. The difference between number of heads and number of tails. Now here number of tails, there are 4 tails, number of heads 2. So what is difference? 2. If you take this value, number of tails, number of heads 1, 2, 3, number of tails 1, 2, 3, so 0. Output will be 0. Here 1, 2, 3, 4, 5, 6. Number of heads 6. Number of tails 0. Number of heads 6. Number of tails 0. So difference is 6. So here, because X calculates difference, we can show this calculation by this way, that tossing a coin 6 times, number of H, number of tail, and here I will keep difference. In this table we are putting all possibilities. If number of heads is 0, number of tails will be 6. If in that output number of head is 1, number of tail will be 5. Number of head 2, number of tail will be 4. Total it will be always 6. So 3, 3. Here 4, 2, 5, 1, 6 0. Now here we keep difference. So difference of 0 and 6 is 6. Here 4, here 2, 0, 2, 4, 6. And what x calculates? Difference between number of heads and number of tails. So here values of x are 0, 2, 4 and 6. These are possible values of x or range of random variable. So this is the meaning of this part. X takes values 0, 2, 4, 6. Find the probability distribution of number of tails in the simultaneous tosses of 3 coins. Say, in the experiment of tossing 3 coins simultaneously, sample space associated with this experiment is sample space as is. We know that tossing 3 coins, sample space is H H H, H H T, H T H, T H H, T T H, T H T, H T T and T T T. 0H, 1H, sorry 0H, 2H, here there are 2H, 1H, 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 0H, 0H, 1H, 2H and 3H. Okay, total 8 outcomes. Now here we want probability distribution of, see, probability distribution of number of tails, probability distribution of number of tails, probability distribution of, say, look here, probability distribution of random variable x. So remember, in given question, if you are asked to find probability distribution, then after this bunch of words, probability distribution of which object? Number of tails. So this is our random variable x, probability distribution of random variable. So this is formula for random variable x. So here we are taking x is equal to number of tails. So here x is equal to, x is from S to R, and in x, when we keep elements of this set S, x of u is equal to number of tails in u. This will be the formula, x equal to number of tails. X calculates number of tails from which element? It calculates from elements of S. So from these elements. So for these elements we are taking u, where u is in S. For every u belonging to S, this is the way of working of random variable. Now see, here x, range of x. Now we calculate range of x. See, when in this formula, if you take HHH, so x of HHH, so number of tail is 0. Then If you put HHT, so number of tails in HHT is 1. Then HTH, so put here HTH, so number of tails in HTH is 1. So whenever you keep any one element from these three, here answer will be 1. If you keep any one element from these three, value of x will be 2. And if you keep a t, then x of t is 3. So x takes values 0, 1, 2, 3. So that is a range of random variable x. So from question we find range of x. Now we are coming on this point. Probability that, see, I am now explaining these symbols. Probability that x takes value xi is denoted as probability of x equal to xi. So probability that, now probability that x takes value 0, probability that x takes value 0, that means probability that number of tails in u in outcome is 0. So this value is associated with which outcomes? Number of x is what? X is number of tails. So number of tails is 0, that means probability of event that number of tail is 0. So here number of tail is 0. So this is associated with this event. When x takes value 0, if this event occurs, so probability that x takes value 0, it is equivalent to saying that probability of occurrence of this event, and its probability is 1 upon 8. Now probability that x takes value 1. So when x takes value 1, that means number of tail is 1. Number of tail is what? X means what? Number of tails. So when number of tail is 1, this is associated with the event number of tail is 1. That means when this event occurs, HHT, HTH, THH, x takes value 1, that means probability that x takes value 1, that means probability that number of tail is 1. That means probability of this event. So this is associated with this event. So probability of this event is 3 by 8. Probability that x takes value 2. X takes value 2, that means x equal to, its value is 2, means number of tail is 2. Number of tail is 2, that means probability of this event TTH, THT, HTT. When this event occurs, that means number of tail is 2. So probability that number of tail is 2, that means probability of this event. Probability that x assumes value 2, this statement we are associating with an event. So its probability is 3 by 8. Probability that x takes value 3, that means number of tails 3. number of tails 3, that means probability that here number of tails 3. If this event occurs, then probability is 3. Number of tail is 3. So its probability is 1 by 8. So say look here, probability that x takes value xi, this statement we are associating with an event. So when this occurs, if this event occurs, when this occurs, if this event occurs, so probability of this is same as probability of this event, so 1 by 8. So therefore probability distribution of random variable x is as follows. Now in tabular form we keep these values. Say x, first line is x takes value 0, 1, 2, 3, 0, 1, 2, 3, and second line is p of x, this is written in short. So it is probability of 0 is 1 by 8, probability of 1 is 3 by 8, probability of 2 is 3 by 8, and probability of 3 is 1 by 8. So this is a probability distribution. So probability that x takes value xi, value of probability is pi. So these are pi, p1, p2, p3, p4. Probability that x takes value xi is a pi. So these are xi, these are pi. And in this table, see, values in second line must be positive. See, all values must be positive, and here it is, and sum of these numbers must be 1. See, 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8, total is 8 by 8, 8 by 8 is 1. So sigma pi is 1. So that's why this is a probability distribution. It is required probability distribution. Say next question is, find the probability distribution of number of successes in 2 tosses of a die where a success is defined as. So here there are 2 sub questions. First question is, if success is defined as number greater than 4. Here 2 tosses of a die, that is experiment. So when tossing, in experiment of tossing 2 dice, sample space contains contains 6 into 6, 36 ordered pairs. We know order pairs 1 1, 1 2, 1 3, 1 4 up to 6 1, 6 2, 6 6. Total 36 elements when tossing 2 dice. Now here we want probability distribution. See, before doing this, let me show as in short 1 1, 1 2 up to 6 5, 6 6. Representation of sample space in short. Now see, we want probability distribution of, look after bunch of words, probability distribution of. So probability distribution of random variables, probability distribution of random variables. So here this is our x, number of successes. So here x is equal to number of successes Now what means success? If output has number greater than 4, where success is defined as, where success is defined as number greater than 4, that is considered as success. Where if output contains number greater than 4, then it is considered as success. That is in this solution of first question. As for example, if you toss a die, two tosses of a die, if you toss a die 2 times, then if you get the result is 1 1. Now look here, is any number in this ordered pair, is there any number which is greater than 4? So here no number is greater than 4, so number of success is 0. Look 1 2, is any number greater than 4? No number greater than 4, so success is 0. Like this. If we take here 1 3, so success is 0. 1 4, no number is greater than 4. If number is greater than 4, then it is considered as success. So here no number greater than 4, so number of success is 0. If we take 1 5, then here number of success is 1. 2 5 1, 3 5 1, 4 5 2 5, so number of success is 1. 3 5, number of success is 1. 4 5, number of success is 1. But if we take 5 5, so see both are greater than 4, so number of success is 2. Clear? So 1 4 1 5. Now if I take here 1 6, 1 6, so number of success is 1. 3 5, number of success is 1. If you take suppose 6 5, so both are more than 4, so number of success is 2. So here x is number of successes, x is number of successes, and number of successes, possible values of x are 0 1 2. So therefore x takes values 0 1 2. So range of x is set containing these 3 numbers. Always check the question, what is random variable? So that is words you can define from words which are after a bunch of words, probability distribution of random variable. This is random variable, the number of successes. And here there are 2 questions. So in first question, what is number of success? So number of success, in this number of success, what is success? Success is defined by this word, that if in output, if you get number greater than 4, then it is considered as success. So maybe 0 success, maybe 1 success, maybe 2 success. 3 success not possible, because we are asked to toss a die 2 times, not 3 times. So here we will find probabilities of this values x. So now, so if you understand experiment, and if you understand what means random variable, what is definition of random variable, then question will be clear. Now probability that x takes value 0, x takes value 0, That means what? Number of success is 0. So when number of success is 0, if this event occurs, so 1 1 1 2 1 3, number of success 0, number of success 0, number of success 0, 1 4, number of success 0. Then don't take 1 5, don't take 1 6. Then 2 1, 2 2, 2 3, 2 4. Don't take 2 5, 2 6, because in 2 5 and 2 6 there is 1 1 success. Then line of 3, 3 1, 3 2, 3 3, 3 4. Don't take 3 5, 3 6. Then line of 4, 4 1, 4 2, 4 3, 4 4. Then don't take 5 1, 5 2, because in line of 5 1, 5 2, 6 1, 6 2, number of success is 1 or 2. So these are the outputs from this S. If any one output appears from this collection, then there is no output containing number greater than 4. And if number is greater than 4, it is success. But here number of success is 0. So probability that X assumes 0, that means it is equivalent to say probability of this event. And probability of this event is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It is 16 by 36. So probability that X assumes value 0 is 16 by 36. Now, what is the probability that X takes value 1? X takes value 1, that means number of success 1. That means in output any one result either on first place or on second place is more than 4. So number of success 1, that means it is equivalent to say probability of this event containing in the line of 1. So 1 5, here 1 success, 1 6, here 1 success, then 2 5, 2 6, 3 5, 3 6, 4 5, 4 6. So here 1 success, 1 success, 1 success, 1 success, 1 success, 1 1 1 success, then 1 success, 5 1, 5 2, 5 3, 5 4. Don't take 5 5. 5 5 means 2 success. Then don't take 5 6 also. Then 6 1, 6 2, 6 3, 6 4. If this event occurs, then each output has only one digit more than 5, means 1 success. So probability of 1 success means probability of occurrence of this event. So its probability is 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16, 16 by 36. Now probability that X takes 2 success, X takes value 2, so number of success 2. Number of success 2, that means probability of occurrence of event in the line of 1 2 3 4. There is no any element containing 2 success. So in the line of 5 5 5, 5 6, here 2 success, here 2 success, then 6 5, 6 6, here 2 success, here 2 success. So these are only 4 outputs in which there are 2 success every time, both times number more than 4. So probability of this event is equal to probability that number of success is 2, so that is 4 by 36. So this is 16 by 36, 4 by 9. This is 4 by 9. This is 1 by 9. Therefore, probability distribution of random variable x is, here x takes values, I am putting here probability of x. We can say x equal to x. This symbol also can be used. So here 0, 1, 2, only 3 possible values of x, and their probability is 4 by 9, 4 by 9, 1 by 9, and you can see that. See, sum of numbers in second line. Sum of numbers in second line is 1, and each one is non-negative. Everyone is positive. So this is a probability distribution of x. Now say second question. Experiment is same, but here random variable x, that is number of success. X is the number of success. Here definition of success is different. Where what means success? Success means 6 appears on at least one die. That is, if 6 appears on at least one die, then it is considered as success. That means if you toss a die and output is 4, 5, then nowhere success. Number of success is 0. If you get 4, 6, then 1 success. If you take 6, 4, then number of success is 1. If you get 6, 6, so number of success is 2. So in short, here number of success means number of 6. So range of x, here x takes, here x takes values 0, 0 success, 1 success and 2 success. That is outcomes contain no 6, 1 6, 2 6. In short, this is the meaning. No 6, 1 6, 2 6. So range of x is, it is set of these numbers 0, 1, 2. Now probability that x takes value 0 means number of success 0, that means number of 6, 0 means no 6, that means probability of event associated with this statement. Okay, number of success 0, that means outcomes contains no 6. So probability of event containing those points having no 6, that is 1 1, 1 2, 1 3, 1 4, 1 5. Don't take 1 6. Then 2 1, 2 2, 2 3, 2 4, 2 5. Don't take 2 6. Then 3 1, 3 2, 3 3, 3 4, 3 5. Then 4 1, 4 2, 4 3, 4 4, 4 5. then 5 1, 5 2, 5 3, 5 4, 5 5, then don't take 5 6, and then don't take 6 1, 6 2, 6 3, etc. These are the elements which are free from 6. So no 6 means number of success is 0. So its probability of this event is, these are 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25. So 25 by 36. Now probability that x takes value 1, that is equivalent to say that probability of occurrence of event 1 6, 2 6, 3 6, 4 6, 5 6, 6 1, 6 2, 6 3, 6 4, 6 5. These elements are containing only 1 6. 1 6 means 1 success. So probability of 1 success is 10 by 36. And number of success 2 means only one element. If this event occurs, then probability of this event is 1 by 36. So therefore probability distribution of x is x equal to x, p of x equal to x. Here 0 1 2. Probability of 0 is 25 by 36, then 10 by 36, 1 by 36, and always check sum of these numbers must be 1. If sum of this number is not 1, it is not a probability distribution. That means maybe possibility of mistake somewhere. If you miss if you miss an element, suppose if you miss something, suppose if you miss this element or this element, then here you will have 24 by 36. Or if you add one extra element, then this will be 26 by 36. So your answer will not be 1. So be careful.